All right, so what we're covering here is just going over the answer key to the first midterm in spring 2015 in Finance 363. Now, one thing to keep in mind on this is that we are looking for very concise, very correct answers. As you'll notice, just missing a minus sign, missing an exponent, doing something in a little bit in an incorrect way will provide us with drastically different numbers. And as such, you know, it's very important for these precision numbers. So what I'm really grading for here is mastery of the concepts. Okay, so we go into question number 1 here. We're showing the present value of three $300 fixed payments received every other year, with the first payment coming at t equals 1. Opportunity cost is 8%. So what I'm doing here is that it's important here we notice that we say every other year, and the first is coming at t equals 1. So we're going to sketch out our cash flows here, right? We have time period 1, 2, 3, 4, 5, and 6. Okay? Now, if we have 3 payments coming every other year, first payment's coming at 1, so we're going to have a payment here at the first year, plus then we're not going to have any payment in year 2, right? Because it's every other. Okay? So we're going to have a $300 payment here, nothing in year 4, and then we have a $300 in year 5, and nothing in year 6. Okay? So all of these here is that we have to discount those back to our present value, and that's going to be the 1.08 to the first, 1.08 to the third, and 1.08 to the fifth. Okay? And all of these are going to come back. And this is all I really needed to see, right? I just needed to make sure that when you were detailing this out is that you had these numbers matching here, okay? You wanted to make sure that if it's coming in year 3, you also have it set up coming in year 3. Coming in year 5, you have it set up as the exponent coming there in year 5, okay? Now, number 2, we're talking about a 5-year annuity starting at time t equals 2. Okay, so once again, we're setting up our cash flows, setting up our years here. And we have 0 coming in year 1, right? Because it's starting at t equals 2. Okay? So then we're looking at our payments of $2,300. Okay? Right? And these are coming for these 4 periods. And then we're as well getting these in year 6, right? And why are we getting them from year 2 through 6? It's because it's a 5-year annuity, right? So we receive these payments for 5 years. Okay, so then we have to discount all of these, right, at an interest rate of 7.2%. Okay, and our exponent here is going to be the 2, right, because we're in the second period. Okay, so we're at the 1.072 here to the third, and we're at 1.072 to the fourth, 1.072 to the fifth, and 1.072 to the sixth, right? And that's all we needed to see. And that's going to tell us that we're going to have the value of this annuity, right? We compute all of this, and all of this stuff comes back to a present value, okay? And we can just plug this in the calculator. We compute these individually, but you were not asked to do that on this exam. All right, then we come to number 3. Present value of an uneven stream of payments, right? So we're looking at an uneven stream. So that means naturally that they are not even. They are not the same amount. Okay, so what we're looking at here is that I want to sketch this out, and we are showing these to be coming in 4 time periods, right? So we have in year 1 here, and then coming out to the end of year 4. So we don't need to write any of the other years out here. Okay, so in year 1 here, I'm paying $400,000. So that is going to be a negative. Okay? And I'm just going to leave off the thousands here. But we have a negative, all right, I'll write them. So we have a negative $400,000. Okay? When we're receiving in year 2 is that we're also going to have to pay $150,000. So once again, that is a negative as well. Okay? But we are simultaneously receiving $180,000. Okay? So that's a positive. Okay? And then in year 3, what we are receiving is we're receiving $360,000. Okay? And then in year 4, I am receiving a payment in the amount of $265,000. Okay? Now, we didn't have to discount all this stuff back, right? We are paying this $400,000 in year 1, which is going to putting it in our opportunity cost of the 5.5%. In year 2, all of this is divided by the 5.5. Year 3, this is divided by the 5.5. In year 4, this is divided by the 5.5. Okay? Now, what we have to look at is now we have to make sure that all of our exponents match up with the year in which they are receiving. So here in year 1, we have that 1 here. Okay? In year 2, we raise that to the 2nd power. In year 3, we raise that to the 3rd. Year 4, we raise it to the 4th. Okay? I think that one is relatively straightforward. Okay? And then all we do is this is going to bring us out to question number 4. Okay? Question number 4A is, suppose the cash flows are for sale, how much are those cash flows worth today? Okay? So what we see here is that we did all of our calculations here, and we could have done this a longhand way, right? We could have done the calculation here, and then added it to this one here, and then added to here, and then added to here. Okay? But we have that easier, quicker way that we can do that using our calculator, right? All right, so on our calculator, we come in and we open up our cash flow here. And what we want to do first off is that we want to make sure that we clear the values out here. So we're going to hit the second clear work. Okay? And we'll see we have CF sub 0. So when we're opening this up is that we have a payment in, we're going to scroll down to cash flow in 1. We have a payment in the amount of $400,000. But we need to make that a negative because we're paying that out. Okay? And we hit enter. We scroll down here to cash flow in 2, and then we have a 30. Hit enter, come into 3, and we have 360. Hit enter. We come into 4, and we have 265, and we hit enter. Okay, we scroll down. We just make sure we don't have anything in here at 5 because it might have been registered for something we did earlier. We then come in and push this NPV button. Okay, and then we're shown here is that our interest rate. So this one here is going to be that 5.5. We hit enter. Okay, we scroll down one more, and now we are seeing our present value here, and we want to compute that. Okay. All right. Now when we do that, that gave us our answer. Their answer here is $168,300. Okay? And credit was given if you were within a reasonable ballpark there. Okay? Now what you notice is that when I was showing you over here is that on question number 1 is we had a number of people, I saw it a number of times where people did not put that negative here in front of the 400. They counted that as a positive value. Now, what the number we see that comes up being hugely different is that we come up with a number of somewhere in the ballpark of $950,000. Now, let me ask you this question. All right, so this one over here on the left, this is our correct answer. Okay? If I was asking you for a value and I was willing to sell you something, and the actual value is this one here. This is our actual value is at $168,300. But you think it's worth $950,000. What is your end result going to be? You're going to end up getting screwed because you're going to greatly overpay for what this is. Okay? So this is why it's really, really important that we make sure that we get things set up appropriately. Okay? Now on B was not actually, I didn't actually grade this one because there was some ambiguity as to whether you owned it or you were looking to buy it. But basically what I was asking here is you see that this is for sale for $168,300. That's the sale price. And then you could buy it for $85,000. Okay, and the question, and would you do that? Absolutely. Absolutely you would do this because you would be making a huge return on that because you're getting it for half price basically. All right, now number 5. If $326, we're just here going to be computing what the value of putting $326 in an account. So we're going to use our basic equation here that our future value is equal to our present value times 1 plus r raised to the t power. Okay? So we have a present value here of $326. And then we have 1 plus our r. We have an annual rate of 3%, so that's our 0.03. And that is going to be raised to our t, so that's going to be 7 years. right? This is what it would look like if we were computing it annual. However, we are not computing this annual. We are computing this as a monthly compounding. Okay, so when we're monthly compounding this here is that we have to convert this interest rate right here, that 3% annual rate, and we have to convert that into a rate that is compounding every month, so 12 times a year. Since we are dividing this part here by the 12, is that we then have to multiply our exponent out here by that time period, 12. Okay. Now, once we do that, and you just run through the math, that gives us a value of $402.07. Okay, and I think it's really good idea to sketch this out here, but you don't have to do that. You can just put it in your calculator. The reason I say it's good to sketch is because you make sure that you manipulate this right here. Make sure you change these values right here, because if you do one of them wrong, you're going to end up being, having an incorrect answer. Okay. Now, number 6, we are looking at here is computing our yield. So this is our yield on an investment that we had. And basically what we have here is we use our equation on our yield, and that is going to be our new minus old over old, right? So it's our new price minus our old price divided by our old price. Okay, so this is going to be our capital appreciation yield. But then we also have to add on to this the possibility of receiving interest payments and dividend payments. Okay. Now, on this question is that what we don't have is we don't have dividends, right? So we don't need to worry about dividends here. Okay, but we do want to know our yield. And so our yield, so our new price is $97, because that's what she sold the bonds. And then we have to subtract off the amount she paid, which was that $101. Okay, and that's divided by our 101. Okay, plus then we also have to add on our interest payments. Okay, so we have these $2 payments, but the important part here is we notice that it's quarterly. Okay, so we have to multiply those $2 payments times our 4 periods. Okay, and that is divided by the 101. Okay, and basically this works out to being 4 divided by 101, which gives us a yield of 3.96%. Okay? Now, in order to get credit on this, you have to understand that a yield is in a percentage term. It is not what my absolute return is, right? Because it's not enough to say, oh, my return was $6 last year. Well, that doesn't really tell me very much. What I need to know is, what is my percentage? What did I actually put into that? What is my return, right? So we have to make sure that everything we do here is in a percentage term. Okay? We have to make sure that everything is in as a percentage. Okay? All right. All right, and just skipping over most of these true-false type questions, just because I don't think they're as important. I think you can find the answers on those relatively easily. But we're looking at number 11 here. Your choice is that you have investor A and you have investor B. So we are looking at which one we're going to prefer. And the one we're going to prefer is the one that's going to have the highest effective annual rate. Okay? Now, investment A is that it has a 5% annual return. Okay? So this one, that is our effective annual rate. We don't have to do anything here. But what we have to do with investment B is we have to take investment B and manipulate that back into an effective annual rate. Okay, so we do this as our 1 plus r to the t, right? And that's going to be subtracting off of the 1. That's going to tell us our effective annual rate. So when we do this, right, it's going to be 1 plus the 0.045. Okay, and our t here is still 1. And then we're going to divide this out by the number of payments that we're going to, or excuse me, the number of compounding, which is 12. Not sure what I did here. Bear with me. And we are dividing that by the 12, and now we are multiplying the outside by 12 here. Okay. And when we go through this, this will tell us then we have, it is 1.0459 minus 1. So this means that our effective annual rate for this one, for investment B, is 4.59%. Sorry, yeah, this should be a 9 over here. So it's 4.59%. Okay, so if we're saying that if they're identical in all other ways, same risk, same whatever, you prefer investment A, yes, absolutely. You would very much prefer this. 5%, right? 5 is greater than 4.59. As an investor, you are looking for the highest return. Okay? All right, this one's straightforward, right? You have a 5-year regular annuity. Okay, so we would sketch this out 1, 2, 3, 4, 5. Has a present value of $1,000, and the interest rate is 10, so we have an R of 10%, right? What's the amount of each payment, right? So we have payment, 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 okay? And then we go the 1.1 to 1.1 squared, 1.1 to the third, 1.1 to the fourth, 1.1 to the fifth, right? And then we solve for the payment. We can do this just using our calculator, and that is, you know, we hit the payment button, we enter the $1,000 in as our present value, right? So I'll just write this out here. Our present value, so how we enter our present value is negative 1,000. I over y is 10. The present, oh, we already got present value. N here is 5. Payment, right? That's what we're solving for. And then we have a future value of 0, right? Because we don't have a lump sum at the end. Okay. Now, number 17. We just took out a 30-year, $120,000 mortgage on your new home. This mortgage is to be repaid in 360 equal end-of-month installments. Okay, if each of the monthly installments is $1,500, what is the effective annual rate on this mortgage? Okay, so when we're doing this is we need to figure out what the interest rate is. So we would basically set this up as, you know, being 1, 2, running all the way out to our 360, right? And the amount of our payment here is $1,500. Okay, and we know what our present value is. Our present value is $120,000 because that's what we're borrowing, right? That's what the bank is giving us. We want to figure out what R is, right? So the way we do that, that's a 2 there, okay, is that we can just plug this in our calculator and we're going to come up with a number. Okay, we come up with a number. Our R will pop up as being 1.235. Okay, that's what's going to pop up. But that number looks kind of funny, right? Because it's like, that doesn't seem right. So the reason being is that these are monthly installments, right? So this is a monthly rate. This is monthly. So we have to now convert this into our effective rate. So we have our effective annual rate. And just like we did on that last one here, is that we're going to have basically here the same thing with 1 plus r raised to the number of periods we have, right? So this is 1 plus 0.01235 raised to the 12th power, right? Because we have to see what it's, if we put something in at this rate, what it's going to end up being at the end of the year. Okay? And that tells us, you know, we end up with an interest rate of 15.87%, okay, which is up here. Okay. And I'll just clarify here just one thing, is that, remember, we are looking at monthly payments. This is just an extension of the other things we've been doing. And, you know, we're just, all we're doing here, this is basically a 2-step process here. The first step is that we were solving for R, right? For R on an annuity. Okay? That's what we were doing. Then the second step that we did is that we then had to convert a monthly rate into an annual rate. Okay? And we did that through the effective annual rate here, okay, which was this method right here. All right, now number 18, this seemed to be one that a number of people got wrong. It's the only reason I'm going to go over this here. But financial intermediation, it's going to be tax-free returns, right? That's what we're able to do, is that banks have a much higher ability of reducing costs because that's their job, right? They also have the ability to diversify risk because they have a large amount of funds, right? So, you know, if they were to make a loan of $100,000, it's much easier for them because they can just, you know, they have a lot more funds and they can buy up a whole lot. So you're not exposed to that idiosyncratic risk, right? If it was one of us and we loaned out $100,000, that's probably going to take the vast majority of our portfolio, right? So they have a large amount of funds and they're able to do that. The second and the last one here is financial flexibility, right? If you were going to go in for a mortgage, you could get a 5/1 ARM, you could get a 3/2, you could get a 15-year, you could get a 30-year, you could get all sorts of different things because the bank has various preferences, various ability, but us as individuals, we don't have that as much. Okay, so that's our midterm. If you have any questions, let me know.